Have you ever just looked up and wondered, really wondered, why is the sky blue? It's one of those first big questions we ask as kids, right? And we see the answer every single day. Well, today, we're going to finally get to the bottom of it.
Seriously, just look up. It's blue. It seems so obvious, so constant, you almost don't even think about it. But the fact that the sky has any color at all is because of this incredible dance between sunlight and matter, happening miles and miles above your head. So yeah, the real question is, why that specific color? Why blue?
So to solve this mystery, we need to do a little detective work. We've got two key pieces of evidence we need to examine. The first is the light coming from our sun, and the second is the air itself, the atmosphere, all around us.
Okay, let's start with our prime suspect, sunlight. To us, down here, it just looks white, maybe a little yellow. But that is a fantastic disguise. Because white light isn't just one thing. It's actually a whole package deal.
So what is it hiding? This. Packed inside every single beam of white light are all the colors of the rainbow. You've got red, orange, yellow, green, blue, and violet, all traveling together, side by side, on this epic journey all the way to Earth.
All right, on to our second clue, the atmosphere. You know, when we look up, it kind of feels like we're just staring into empty space, but we're absolutely not. We're looking up through a vast ocean of air, an invisible blanket made of countless tiny molecules, mostly nitrogen and oxygen.
So, we've got our clues right. A rainbow of colors pretending to be white light, and a sky that's secretly jam-packed with tiny molecules. Now for the action. This is what happens when they finally meet. Let's call it the Great Scatter.
As that sunlight plunges into our atmosphere, it doesn't just get a free pass. It immediately starts bumping into all of those little air molecules. And each one of those collisions is like a tiny explosion that sends the light careening off in a totally new direction. And this whole process is called scattering.
And this right here is the absolute key to the entire mystery. Because think about it. If all those colors, the red, the green, the blue, if they all scattered equally, the sky would just look white, right? Kind of like a faded, hazy sun, but they don't. And that difference, well, that changes everything.
So here's the deal. Light travels in waves. Blue light has these really short, choppy waves. Red light, on the other hand, has these long, stretched-out, lazy waves. Now, those tiny little air molecules, they are the perfect size to get in the way of the short blue light, bouncing it all over the place. But the long red light waves, they tend to just cruise right on by, hardly bothered at all. So what you end up with is red, orange, and yellow light continuing mostly in a straight line from the sun. But that blue light, oh man, it gets bounced around like a pinball in every single direction. Up, down, sideways, it completely fills the dome of the sky.
And hey, if you want to sound really smart, this whole process has an official scientific name, Rayleigh scattering. It's just the formal way of saying that tiny particles are way better at scattering short wavelengths, like blue, than they are at scattering long ones. And that's what brings it all back to you. When you're standing here on the ground and you look up at any random point in the sky, the light that's actually hitting your eyes is overwhelmingly that scattered blue light, coming at you from all directions at once. And your brain just processes that signal and says, yep, the sky is blue. You know, a good theory should be able to explain more than just one thing. So, if this scattering idea is correct, can it explain why the sky turns those amazing colors at sunset? Let's put our theory to the test. So here's how that works. When the sun is setting, it's really low on the horizon. That means its light has to travel through a much, much thicker slice of the atmosphere to get to you. And on that extra long journey, almost all of that short wavelength blue light gets scattered away long before it can reach your eyes. So, what's left? Only the longer wavelength reds and oranges are able to make that full trip straight to you, painting the sky with those spectacular colors.
So after looking at the evidence, seeing how it all works, and even testing it against the sunset, it's time for the verdict. What is the final official word on why the sky is blue? Well, first, let's just quickly bust some myths. It is not because the sky reflects the oceans. That's a super common one, but it's not true. The sky is blue over the driest desert on Earth. And it's not just some optical illusion. It's a real physical thing that's happening up there.
So if you remember just one thing from all of this, let it be this simple sentence. The sky is blue because the molecules in the air scatter the blue part of sunlight more than they scatter the red part. That's it. That's the whole secret.
It's really just an elegant answer, isn't it? There's no magic to it. It's just simple physics playing out on a massive planetary scale above our heads every single day. It's a constant, beautiful reminder of how the universe works. And knowing this lets us ask even cooler questions. We know why Earth's sky is blue. But what about another world? Think about Mars. It has a very, very thin atmosphere, and it's full of fine, reddish dust. So, based on everything we just learned about light and scattering, what color do you think the sky is on Mars? I'll leave you with that one to think about.